In this lesson, you will learn how to chain together conversion factors to solve multi-step dimensional analysis problems. We will be using examples involving steamships, like the one shown in the picture here. These are large ships that carry people and cargo locally and around the world. Dimensional analysis is a very powerful mathematical technique. Even if you know how to do some of these problems using a different way of doing math, also try to learn how to do them using dimensional analysis. The world's a very big place and covered with oceans where people can't drive. So if you want to take a trip between two places, sometimes you have to connect through a third. For example, there might not be a direct flight between your starting city and destination. So you could first connect by flying through a city in the middle before flying on to your destination. We're going to apply this metaphor to dimensional analysis problems. But first, let's remind ourselves that dimensional analysis is a creative way of multiplying by the number 1. When you multiply any amount by the number 1, you get the same amount at the end. Let's review a dimensional analysis problem. Which conversion factor would go into the middle of this problem to solve how many quarters are equal to 50 dimes? So the correct answer is B. 4 quarters over 10 times will solve this dimensional analysis problem. The reason for that is that in any conversion factor, the numerator has to equal the denominator. Although this fraction could be simplified to 2 quarters equals 5 dimes, it's completely acceptable to say that 4 quarters equals 10 dimes. The numerator equals the denominator. Also, we want to point out that the unit of the starting amount has to be the same as the unit in the denominator of the fraction. And the unit of our answer has to be the same as the unit in the numerator of our fraction. Options A and D, while they are mathematically equal numerators and denominators, are flipped from that correct order. Dimes needs to be in the denominator and quarters needs to be in the numerator, and options A and D are backwards. Option C, on the other hand, is incorrect because the numerator and the denominator are not equal, and so therefore it's not a valid conversion factor. We also want to remind ourselves how the math of this works. That what we're doing when we're multiplying fractions is it's all like it's one big fraction. And anything in the top in the numerator that's equal to something in the denominator can cancel. So dimes is equal to dimes, we can cancel dimes, and dimes goes away. Then when we do the math out, we're going to multiply across the top. So 50 times 4 is 200. And also the word quarters is left, so we're going to copy quarters after the equal sign. Then we multiply across the bottom. 1 times 10 is 10. So multiply across the top, multiply across the bottom, and then we divide because a fraction bar is a division symbol. And we got the answer is 20 quarters. Right. But we can also multiply by 1 as many times as we want to, and we'll still get the same number at the end. So we can do it once, twice, 3 times, 4 times, as many times as we want. That means that we can string together conversion factors because each conversion factor is equal to 1. Remember that a conversion factor, the numerator and denominator, must be equal for this to work. That's how the math works. If we multiply by 1, we get the same amount at the end. If we multiply by conversion factors where the numerator equals the denominator, all we're doing is multiplying by 1. So let's see a specific example of this. Let's imagine an example where a steamship takes 25,200 minutes to get to its destination. How many days is that? Well, I'm going to use the metaphor of traveling between countries. If a steamship were to go from Mexico to Canada, it would have to go through a port probably of the United States first, or near the United States. Just like if we're converting between minutes and days, I don't know off the top of my head how many minutes are in a day, but I do know an intermediate unit that I can use. So instead of having to look up minutes to days, we can go and look for a unit in the middle, just like the ship would be going by the US in the middle between Mexico and Canada. And that unit is going to be hours. By the way, there's a typo there. Minutes should not have changed to hours in the example. All right, so let's go back to the original math. So if a steamship takes 25,200 minutes to get to its destination, how many days is that? So we know how many minutes are in an hour. We know how many hours are in a day. Hours is the intermediate unit. We now have 2 conversion factors where both of them can be turned into fractions that equal 1. So what we're going to want to do is put the starting amount, which is the number in the problem at the beginning. We're going to want to cancel our first unit by putting 60 minutes in the denominator. That's half the conversion. And we're going to want to put the other side, 1 hour, what it's equal to, in the numerator. That will cancel minutes and give us hours. We then want to cancel hours because remember, hours is an intermediate unit. We don't want hours at the end, we want days. So we'll make another conversion factor where hours is in the denominator now. So now hours will cancel the hours that were left over from the previous step. And then it's equal to 1 day, and days is in the numerator. And so therefore our final answer will be in days. When we plug all those numbers in, we can see that this becomes really one large fraction. So we make one big fraction bar, and we multiply across the top, we multiply across the bottom, and we divide. We also want to remember that the reason that any of this works is that if a unit's the same in the numerator and denominator, they will cancel. So minutes will cancel minutes, hours will cancel hours, and days will be the only unit that's left. So when we multiply, we'll get 25,200 days in the numerator. We'll get 60 times 24, which is 1440 in the denominator, and then we'll divide that fraction and we'll get our final answer, which is 17.5 days. All right, try it yourself. A steamship takes 1.25 weeks to get to its destination. How many hours is that? You probably don't know how many hours are in a week off the top of your head, but you do know an intermediate unit. What's a good unit to use between weeks and hours? What's something in the middle that we can connect through? So the answer would be days, because we know how many days are in a week and we know how many hours are in a day. So days is a good midway unit. What's the first conversion to use to solve the problem? So sure enough, the best conversion to use is 7 days is a week. This is a good conversion factor because we're going to cancel weeks, which is our starting amount. We need weeks in the denominator of our conversion factor. Also, the numerator is equal to the denominator. In options A and B, in option B, the numerator is not equal to the denominator. Option A is just too complicated. We don't need to go doing any calculations to look it up. And also, it's upside down. Option C is also is also an unacceptable conversion factor because the numerator and denominator are not equal to each other. So what's the last conversion? Remember, this conversion is going to cancel weeks and leave us with days. And then we want hours out at the end. So the answer is A, because A will then cancel days, which is our intermediate unit, and leave us with hours at the end. Also, the numerator is equal to the denominator. Option B is the same conversion factor, just upside down. Option C isn't acceptable because we're not looking to go back to weeks. We really want to, actually, there's not even 24 hours in a week, are there? So it's not actually a valid conversion. And same thing with D. D is also not a valid conversion factor because the numerator and denominator are not equal. So solve the problem. So we get at the end 210 hours. Pretty much all we had to do was multiply those three numbers because there's no number other than 1 in the denominator, and all the units cancel except for hours. All right, let's look at another example. In this one, we're going to convert 6.0 inches to yards. This is an example using distance. Thing about distance is there's lots of different ways of measuring distance. There's metric conversions that have centimeters and kilometers, so we know those kind of conversions. Metric, another name for metric is SI, or the International System of Measurement. We have US customary conversions. We're used to these in the United States, like inches and feet and miles and yards. And we have metric to US conversions, which are the way that we get back and forth between the metric conversions and the US conversions. In this particular, one thing that I want to go through right now is that there's a whole universe of units here, and it can be really helpful to kind of map out their relationships to each other. Every unit that's up here can be represented by a box, and then we can represent connections between them by arrows. So if we look at just the first box here, meters, centimeters, and kilometers are all units that are shown in that first set of conversions, the metric conversions. And you can see that meters is connected to centimeters, and it's also connected to kilometers. So we can represent that by arrows, right? I didn't draw an arrow between centimeters and kilometers because I don't have a conversion available to me that connects the two of them. I'm sure we could look one up, but it's not necessary because we can do multi-step conversions. We can just use the simpler ones to connect centimeters and kilometers together in 2 steps. Then if I want to get to the US system, I have a conversion between centimeters and inches, and then we have another conversion between kilometers and miles. We can use whichever one's the most convenient for us. And finally, in the US system of measurements, I know how many inches are equal to a foot, how many how many feet are in a mile, and how many feet are in a yard. And so we can represent those 3 conversions by these 3 arrows here. The point being, whenever we do any conversion in distance, we can use this kind of like a map to figure out which conversion factors we want to use. So in this particular example, we're looking to get between 6 inches in yards. And so if we look down at these conversions, we find out that sure enough, inches and yards are connected by feet in the map. So we can use those conversions, the conversion between inches and feet and the conversion between feet and yards. So this is how this would work out. We would first put 6 inches over 1 because it's the starting amount. We'd use that first conversion between inches and feet and make sure that inches is in the denominator so it cancels and feet's in the numerator. And finally, we want yards at the end. So we'd have to go and put 1 yard over 3, it should be 3 feet, not 3 hours in the denominator there. And so we can cancel the units, and we're going to get an answer at the end of 0.17 yards. So again, that's 6 divided by whatever 12 times 3 is. Right, so inches cancels inches, feet cancels, well, that's supposed to be feet. And so yards is the only unit that's left, which is why it's the unit of the answer. All right, when you do dimensional analysis, always check. Do all your numbers have units? That's important. Do all your units cancel? That's also important. You should only have the unit left at the end that you expect to be left at the end. And finally, are all the values in the conversion factors equivalent? In other words, the numerators and denominators of all those conversion factors have to be equal to each other. And if they're not, then you're not going to get the same answer at the end because you're not really multiplying by 1. So in this particular example, we have all the check marks there. The 2 green conversion factors, the numerator does equal the denominator, and all the units do cancel properly. All right, so let's do a problem yourself. Imagine a steamship that travels 7.5 times 10 to the 5th yards. That's in scientific notation, but that's really just 75 and 4 more zeros. So 75, 750,000 yards, essentially. How many meters is that? Well, remember our map? If we ask ourselves which conversions we should use, we'd have to find the conversions that go between yards and meters. So what conversion should you use? Pause here to look. So sure enough, you could go from yards to feet to miles to kilometers to meters and connect the units together. That's a pretty long connection, but it works. There's actually another one as well. You can go from yards to feet to inches to centimeters to meters. I prefer the first set, so please set up the math for the problem using those conversion factors above and solve it. So when we put these together, we're going to have to cancel yards first, go to feet. Then from feet, we go to miles. Then from miles, we go to kilometers. And from kilometers, we go to meters. And we can see that the units are all going to cancel except for meters. So what's the final answer? So at the end, we're going to get 6.8 times 10 to the 5th meters, or if you prefer not using scientific notation, 680,000 meters. That's a rounded number. All right, so in this video, we're learning about multi-step conversions. We've learned that we can multiply by as many conversion factors as necessary. We can break down big trips into short trips where we know the conversions between each destination, and we can cancel each conversion factor one at a time on our way to our final answer.